Let me 6 seconds.
So we'll just start taking people in now.
Okay.
Sure.
Okay, I think we should start now. It's just 11:02. Good morning and welcome to everyone. Thank you for joining this webinar. And we're so glad that today our webinar series on business continuity is going deep into the industrial segment. And this is something which we have been really looking forward to, getting to know and hear more about Industry 4.0 and IoT and automation, which is definitely something that everyone in the western part of India, Gujarat, Maharashtra, is always looking forward to. So today we have a very special friend, a guest speaker, and as you might have already seen on his introduction that we gave you, he's not just a founder of this company, he's an innovator, technocrat, he's a drummer, and then he's an business coach, and which is one of the questions which I'm going to ask Mihir today. So welcome Mihir, good morning, and how are you doing today?
Great. Good morning, Devang. Thanks for that.
And we can see that drums behind you. So are you going to give us a live jamming session or something today?
I'm sure at the end of the session, if you think we should, you'll just hear a lot of noise.
Or maybe I can just play a small clip from Warsaw,
That one makes sense. Yes.
Yeah, Okay, so before we start, Mihir, I want to just give everyone a formal introduction of you. So if you would just allow me a couple of minutes to just read out something about you. So Mihir Ganguly is a successful visionary and entrepreneur with over 26 years of industry experience, with a bachelor's degree in computer engineering from RIT Mumbai. Born in Bangalore, he spent his student life in Bombay, and then he came back to Bangalore to start Protocol Consultants in 1994, which is one of India's first software services company focused on developing and implementing software for the manufacturing industry. He was the first to bring open industrial technologies like OPC, which is OLE for process control, in 2003. And since then, he has been propagating it by bringing in, sorry, professional based training services in the area. He's a pioneer in bringing IoT in India way back in 2010 when IoT was just a concept. Today, it's a buzzword. Meir has been successfully implementing unique concepts of automation in various industries like steel, foods, and discrete manufacturing. And
हाँ है सर हेडफोन
some of the most innovative technologies have been adopted for companies like ITC Foods for their bingo chips plant, which help to increase the overall equipment efficiency of 4 lines by integrating varied machines and departments. Then for Tata Cummins, where he created an online truck engine line management system, which picks data from the line and creates an online manufacturing execution system, NES, which is what we are also going to cover today, to help optimize speed and troubleshoot issues during the manufacturing process. One of the projects which he's particularly proud of is with Bhabha Atomic Research Center, BARC, which provided redundant open system SCADA software, which could populate 10,000 points every second. One more for Punjab State Electricity Board, wherein they set up a remote monitoring of 650 substations throughout the state using GPRS technologies. And repeated the same thing with West Bengal State Electricity Board and Maharashtra Pradesh State Electricity Board. In 2001, he was recognized by International Association of Business Leaders as a leader in bringing low-cost software automation technologies to small and medium manufacturing companies, allowing for them to also benefit from using online quality and automation systems to improve manufacturing standards. Mihir particularly belongs to a family, and I'll not just disclose all the secrets, but he belongs to a very sort of an artistic and a music loving family. And so music has been part of his life throughout, and you can make out with that drum set in the background. We all try to use these Zoom backgrounds, but he wants to use his drum set as his background. So he's currently part of a band in the making called Amnesia, but has played with before with his first band, which was 11th Hour, at many gigs in the Bangalore circuit. He has also played jazz with Italian guitarist Frank Scarfone, and though he likes to play all genres of music, his personal favorites are funk, modern jazz, classic, and soft rock. He also coaches people on how to live their life freely by working with them to search for their truth and purpose. He calls this process isness. And so whenever you get a chance, Mihir, do speak a few things about that. He lives in Bangalore with his wife, Monica, and two daughters, Isha and Kea. Over to you, Mihir.
Great. Thanks, Devang. That's an amazing, a long but quite wonderful introduction.
I
Thank you
shortened
so
it, by the way.
You did, okay. Thank you so much for that. I'm really happy to be here today, actually, because this is something very close to my heart that I've been trying to spread many years back. I only had a few clients, who are maybe top line manufacturing, like the names you've suggested, ITC and the Tata groups, and the cement factory, the Birlas. They're the few of them who have spent energy understanding this. But today, I'm so happy that we're able to address much larger business areas. For me, this is a dream that India actually, wakes up to bringing IT to the shop floor. I remember doing it in 1994, and I had only laughs from people on the shop floor there that a computer will never run their factory. But today, it's become such a need, and it's become such a default, and it's amazing to be part of today's discussion. So what I'll do is I'll start moving on with the presentation today. I think Devang has set up a few polls in between. We have a chat bar that's there on the left where you can post questions as well. We will be having a Q&A session at the end in case you need that space as well. But as you do so, I might answer the question immediately, or I might find the right slot during my session to answer it. But please feel free to type in questions there as you see me present. There are a lot of concepts going to be shared in today. So there's a lot of information you'll be receiving this morning, and therefore I'd like you to digest all of that and decide what to put there on the chat box. So basically, I run a company called Protocol Automation Technologies. Like Devang said, we are a industrial software solutions with close to around 3,000 clients in India, in the Middle East, in Canada as well. Headquartered in Bangalore, and we basically focus on solutions that are application-based rather than writing code from scratch. One of the reasons we took that path very quickly was because we realized we could deliver solutions quickly to customers and make sure that the necessary support and structure was there in place. We spent a lot of time beginning with visualization and control systems in 1994. Like I said, India was new to the concept. Most factories were not comfortable having a computer actually control their factory. So those are the energy points, when we began. That was where we specialized, and we still specialize in that space. Like Devang said, we do a lot of OPC, which is OLE for process control. It's communication systems and a standard that's used, as well as offer certified training. Industry 4.0, obviously consulting and IoT consulting there. We also build IoT devices. One of the learnings we've had in the past 13 years of implementing it before it was IoT was to realize IoT devices are not necessarily off-the-shelf boxes, and they need to be customized many times for a client need. And we work with a lot of embedded companies to build these as well for automation, advanced metering infrastructures, energy, and different types of things. We have a large system integrator base, and today we are working with iValue because that's a region we haven't spent much time in, and therefore having someone like iValue there, Devang there, makes us very comfortable working with clients, because then someone local looks after clients. India is a large country. It's not easy to reach customers all across the place. And we normally work with someone like iValue in different countries as well as in India, in different states, to help us to approach clients and make it easy. Focus, of course, has been simple to support and to train. So whatever solutions we offer, we ensure there's a strong support and training space attached to it. A quick overview of the different solutions. We basically have infrastructure as one of the space. India is fast growing in this space in infrastructure. And of course, like I said, the Industry 4.0, which focuses on manufacturing. In the infrastructure, we do automated meter reading. And Devang shared a few of our clients, Madhya Pradesh State Electricity Board, Punjab, West Bengal, Assam. All of these states are using solutions where they pick up information using IoT devices from their customers' energy meters, which they have installed, and are able to do billing, understand the distribution of power to their customers. They have GIS information systems which allow them to understand which grids are working and which are not. So it's quite incredible that India did this about 15 years back, began this process. We spent a lot of energy with Power Grid to educate them that they could use and trust the mobile technologies at that time, which were not as good as they are today, but they were decently stable at that point as well. Similarly, for manufacturing, energy management solutions are there. Many customers implement them as well. They've been there for a while. But the missing link was understanding money spent on energy. So we basically wanted the finance person to be involved in this as well, not leave it as a technology space. And we normally show the rupee value that's being, for the asset that you're spending money on. That instantly makes you realize what type of costings you have. So we built a solution that focuses on that. We then have a solution for building management, where we manage utilities and monitor them. This is done, a lot of our projects are with the metros in India, right from Bangalore, Chennai, Jaipur, Calcutta Metro, and Delhi Metro. All of these metros use our solutions there for monitoring their utilities there. Of course, we have some private companies as well who use this as well. What's interesting is a few years back when toll roads became a standard for us, and we had highways that were run well, and we had great roads. The next point that NHAI, that's the National Highway Board that works on focusing on these technologies and working with vendors like L&T and stuff like that, they came out with a need that all the equipment on a national highway should be monitored, and therefore diagnostics should be done live in real time. And there should be only 1 hour. They had a 1 hour window to repair any equipment that failed on a specific road stretch. So L&T does a project for 100 kilometers. They have cameras, they have variable message displays, they have phone booths, different technologies, weather stations, and things like that, or even technology that reads the cars, the frequency of vehicles that are moving, and they have to do diagnostics. We have solutions that focus on that. On the manufacturing sector, like I said, we do communication systems. We help customers to bridge all their automation systems together, and people buy things. If you're a factory that's running for 10 years, you would already have multiple automation systems running sometimes, and we help to bridge all of that together to make it consolidated. Once we consolidate data, we look at actually creating MIS solutions around that, because data is all over the place. People want a centralized location which they can use, and web-based to make it simplified. The SCADA solution, which is the oldest thing we've been doing, is basically for control solutions on the automation shop floor. And finally, like Devang said, today we'll be focusing a lot on the MES, which is focused on the Industry 4.0. The IoT part helps us to bridge a lot of these solutions together. We've done IoT on toll road solutions. We've done IoT for energy management. We've done IoT for automation as well. So IoT is like a central, I would say the sticking point between many of these applications that we have been working on. Some of our clients quickly, these are government clients. Some of them already shared with you. BRC, my favorite. It took us a while to prove to them, work with them, and it's prestigious always to do something for India. So when an Indian government organization like them standardizes on something we're offering, it's quite a nice feeling. We have a lot of energy solutions and stuff like this, which we've already talked about. Some of the private companies that we have worked with are ITC, like already shared, Bosch, Cummins. A lot of cement factories that the Birla Group have a lot of our applications for MIS and SCADA. Tata Steel have a small MES kind of application running. All of these companies have been using this for quite long, I would say for many, many years. These are some of the OEMs we work with. That means these companies manufacture products and they take a product, white label it, and sell it to their clients. BHEL uses it for remote managing their thermal power plants. ABB and Yokogawa use a lot of our OPC solutions and SCADA solutions. Unitherm use a lot of our weighing solutions. So these are OEMs that work with us. Over the years, we've had a long association, maybe 20, 25 years with many of them. And they keep buying and working with us, using our technologies to supply and append it with their technologies to give a better offering to their customers. So what are we doing today? We're looking at Industry 4.0. We're looking at how IoT and big data come in, the tools that we can use for manufacturing. What should it fulfill? If you have a tool, and what should it do? What are the different departments that we should be looking at? And finally, moving a little to the industry 5.0. Though people cover AI into industry 4.0, it's actually not part of 4.0. It's part of 5.0, which is evolving. This is true because if you look at industry 4.0, it actually began way back in 2011. So 2011 to 2020, that's already 9 years in the making for industry 4.0. When Germany and the industrial countries in Europe decided to push their manufacturing to the next level and ask customers to really start looking at digitization. So 5.0 is what we're looking at now, which is obviously, if 9 years are up, India has some catching up to do. But this is why we're here presenting today and hoping that we would catch up soon, sooner than later. So this is the history. If you look at what Industry 4.0 and the different 1.0, 2.0, 3.0 is all about. We had the 1.0, which was production of machines, and the old industrial revolution that began with steam as the impetus to make machines work. Then we increased those lines because we could do mass and use electrical energy to do it. In 3.0 is when automated production began. That's where India currently is. We are at the 3.0 point. We haven't really moved beyond automation yet. We are still at the trying to get automated, and some of us are automated. So a lot of the since I have been operating since 1994 to now, I can see 3.0 has well evolved. But 4.0 becomes critical because one is that we have seen that during times like this, with COVID coming in and putting us down, and then we're suddenly wondering how manufacturing should start up. Is there a way out? How do we get more efficient suddenly? China taking a backseat suddenly, people wanting to move to India for manufacturing. Is India ready? Is India ready to start giving systems and technologies and services? Of course, we have been doing that for many years, for many international companies we supply. But the aspect is, can we get really, can we really get efficient enough to make sure that our bottom lines are protected and we're comfortably making and doing business, increasing business, and yet ensuring we know exactly what's happening in the shop floor without losing anything. So that's where Industry 4.0 comes, and that's what Germany began in 2011. Bosch, in fact, was one of the companies. The Bosch MD at that time was the one who initiated this process, and it took on from there. So if you're looking at what Industry 4.0 should be focusing on, I mean, what really are the problems that we're facing that should be taken care of? And basically, if you look at it, if your manufacturing is not agile, it's not efficient enough. That is the first point which I've been sharing. Second is, if you have a poor response to changing of your process. If something goes wrong, events change and you can't respond, you get delays in actually supplying material. Customer requirements changes suddenly. Can you change effectively, quickly? Market conditions change. Okay, COVID comes in. What do I do? Can I optimize? Can I still produce? Equipment failures. These are important points. People spend a lot of time on large equipment failures and forget the smaller ones, which actually also create downtime and production downtime. So very important. If these are the things that you're already facing, then Industry 4.0 is what you should be looking at. Something that we've always missed, and though some of us are active in it because we believe in it, is key performance indicators like overall equipment effectiveness. What's my machine doing? Is it really efficient? I bought a machine. I spent 50 lakhs buying that machine. I spent 5 crores buying a machine which does specialized activity. What is it? Is it really giving me the output that it's meant to give? And those measurements are critical because it's when I go back to the OEM, I'm working with a German company or a Japanese company that I got in, or an Indian company for that matter. Indian companies are also creating these type of machines. Am I really achieving what I thought I'll achieve when the guy came and sold it to me? And not only to do this for machines, but also to look at, am I doing it for departments? Do I know my departments are efficient enough on production? Is the plant efficient enough? Is that specific line efficient enough? So very important to look at measuring this. And what we all forget is my labor. Without them, I can't even run. I can have as much automation, but I still need someone to start, switch, flip it on. And you need someone there on the shop floor. And it's important to understand I can measure their performance as well. Understand, do I need to help them? So these are things that are missing. If they're missing with you, then Industry 4.0 is something you should be focusing on. ERPs, people have invested on software for ERP, and they have these things running. The missing link is basically people type data into the systems, consolidate data over a week, push that data in. And then you're realizing these values are not necessarily real and could be adjusted to fit in. So ERP, though it's a business system, does not really give you the output because you're not really seeing systems and real-time data from the shop floor into business systems like that. There's no gap analysis done, quick analysis. What's happening in the shop floor? What needs to be done now? Can I repair it? And can I move forward and make sure production runs? If you're having these issues, Industry 4.0 makes sense. Material consumption, again, something that we take lightly because we always work on how much money do I have and do I need to spend on it? If you're looking at having just-in-time manufacturing, then it makes a lot of sense to look at consumption patterns of materials. What's on the shop floor? What's getting consumed? Is there enough stock available to produce the next batch for the next client? So we're very quick in taking orders, but we don't realize we have enough stock yet. Okay, and by the time we order it, production halts because material is not available. Or once you understand the patterns, then you're always just in time to ensure that manufacturing gets there. So Industry 4.0 focuses on this, and the way it does this is simple. It has one simple coin word: digitization. It says bring everything to the IT systems. Try as much to automate. That means if you have physical machines that are doing jobs, make sure that they can be automated as much as possible. Of course, automation is not a cheap process. Buying sensors and installing them are not cheap. But even then, if you're looking at manual processes, try to make sure that you can capture data from those locations and understand what they're doing at what time so that you can understand your whole process. So digitize as much as possible. Like I said, if you're looking at manual processes, then make them web-enabled, use PCs, tablets, smartphones to capture data. If the machine can't give me data, the human being can give me data. So if the human being can touch, and thank God we have touch today, everything becomes simpler. There's no need to type data anymore. Everything's available by just someone clicking something on a screen. Make it web-enabled. One of the reasons for web-enabled is make it very, very light on the shop floor. Make it so light that it's easy to enable any type of system. You could have a Linux hardware running which just has a browser, and you should be able to capture data from that location. So without putting too much pressure on people to buy large, expensive infrastructure, there's potential when you use web technologies to do this. Next, they focus on abolishing the pen and paper. What they mean by this, basically, what Industry 4.0 basically pushes, is try not to write and read stuff from documents that are there on the shop floor. We normally have paper moving right across the factory. We go to most factories, even the most modern ones, and we find that they'll have a file on the shop floor, which they'll open up, which would have come from the purchasing department, and then the planning department, and they'll have all of these documents there, and they need to put it up. They normally pin it up. The problem with this is basically if I'm typing, authorizing stuff and using pen and paper, delays occur because things are not available, things get damaged on shop floors. Manufacturing is not always a clean environment. It's sometimes a very, very tough and dirty environment as well. Many of our manufacturing, like steel, coal, power plants, they're reasonably dirty. How do I move paper through there and still track? So the thing is to abolish pen and paper, maybe look at having electrical drawings, videos related to data that's there, not to bring information to the shop floor, make sure it's available on those web terminals that we can put out for the operators there. So abolish pen and paper by making sure no data entry is made, no writing is done on the shop floor, creating authentic movement of information on the shop floor. Finally, though we invest a lot of money, some of us have Tally, we have an ERP, we have different things, quality systems, automation systems. Idea is to integrate all of this into one system that can look at all of it, consolidate. One of the reasons is simple. If you have two systems, the idea is if data is already entered in one system, not to retype the data in the second system. When you integrate, it means you're pulling information from one system if it's already available, and also giving information that is needed by the system where they don't need to copy it from you. So whenever someone retypes data, you start having errors. Human errors is a standard problem. Instead of writing 22.50, I put 21 or I put 50. I don't realize I made a mistake. And therefore errors take place. Therefore, the resulting metrics that we do create problems. So basically integrate all IT systems that are there on the shop floor. So if you're looking at Industry 4.0 as a small little box, and you're trying to understand what are the different things, you have the sensors, the monitoring tools that many of us already have, and the automation, which is on the left. That's many of us already doing that, where we have started to bring our information to automation to make sure our manufacturing is quite good in terms of the quality of the products that we make. We have brought it to safety and quality, but there's a lot of things that are missing in terms of understanding this information and integrating it, having networks that can help, using technologies like augmented reality, for example, where touch is not required, because thanks to COVID, I did this session last week, and someone asked me there, Mihir, what about COVID? We don't want to. You're talking about maybe biometric, and we're wondering, is biometric making sense anymore? Because it's got someone has to touch a sensor, and I was like, correct. I said that's right. But Industry 4.0 says use technologies to integrate, which could be augmented reality, which would have a glass on, and you could see the screen, and in the air you could be actually doing the activities that you're looking to control, looking to read, see information through your glasses rather than through a computer terminal sometimes. So things are moving fast, and all these technologies exist. And having apps on the shop floor, like I said, you could have mobiles and have apps that could capture this information as well. So Industry 4.0 is all of this that you see on the screen, bringing it together and integrating all of it together. That's the focus of it. And if I do spend energy there, the next question that pops up is, so what are the different technologies and what should I be spending energy on? What are the things that I must be focusing on? IoT is one of those words that seem to be coming up and cropping up. People don't know why they say IoT. They don't know whether they need it. They don't need it. What really is it? And there are so many people talking about it. There's so many vendors out there who are sharing information. So I thought it's a good idea to share with you as well what it really means. As the name suggests, it says Internet of Things. It means I'm going to use internet, and things are my devices, and I'm going to use the internet to connect those devices. Now, on a factory shop floor, most manufacturing would not want to share their data on the internet because I don't want to. I don't want my competition and the threat of cybersecurity, people hacking and taking information. So people are afraid, but they don't understand IoT because people say, no, it's about efficiency. It can change things. Depending on the industry you're in, you'll notice IoT was well established as a technology when we had, if you have caught an Ola cab or a Uber, immediately that they were already using IoT because they used the device, which was your mobile phone, and then they ensured you could catch a cab, using it. So service industry, excellent place for IoT, excellent place because they can straight away use internet technologies from a device and through the internet to create business strategy to make you get what you want. Amazon, all of these companies use Internet of Things because the mobile phone is the device, and finally you get what you want, in terms of the business that you want to run through you or give to you. IoT went well for the power industry as well, or remote applications. So if you're looking at where IoT goes, it should be reasons that justify it being where I can use internet effectively. If I have a remote site, I need information from it. Solar plant applications. If you notice, solar plants are remote. They are in villages, and they want data to be coming in from there and centrally monitoring it. Then they would use IoT technologies, ensuring, of course, that the security layer is built in well. So IoT is about devices that can pick information from whatever technology you're running, bring that data, use the internet, transfer this information, and bring it centrally to you where you can visualize and process that data. So Internet of Things obviously open up a lot of doors for many people. It allows you to start establishing that type of space as well. Another business industry that can well use IoT is water distribution. Excellent place. Water distribution where everything's remote. I have valves running everywhere. IoT devices can help start working and getting information related to it. So IoT helps again in one aspect. Obviously, you need the internet running wherever that remote area is, but it also makes it wireless. Therefore, cabling, fiber networks don't necessarily need to be needed for long kilometers of data. If I have a mobile tower somewhere, it will work to help me use that technology to bring information. All IoT applications are not the same, and everything doesn't use a mobile phone. So it's important to understand what device will help you there. We spend a lot of energy understanding what the customer wants and then designing something that will help them. We have done that for our power applications as well. I think West Bengal was one of the governments that we had to customize an IoT device for them because they had a very specific problem at their sites. So that's a little bit about the IoT part. I'm sure you'll have questions here as well because IoT is an open.
Here,
yeah, go ahead.
Yeah, I think we should just launch the first poll. So let me just launch the poll and give everybody maybe about 30-35 seconds. So to all the participants, when we launch the poll, you will see a poll appearing either on your screen or it will flash in the poll dialog box. It should be there on your screen now. And so you can quickly click and respond to the poll. and we'll leave it open for about 25 seconds. Yeah.
And Devang, what I'll do is I think there are some questions that came up as well. So the moment the poll's done, I think we can maybe answer that as well.
Yeah, so there are 3 questions now, and I think let's just, I'll let you address the questions. And
Perfect. And just once the polling is done, we'll address the, or maybe I can do that right now. I have a question from Ajay. Is it okay for Ajay Vaishnav? He asks, is it okay for medium-sized engineering companies to go for this type of technologies? Terrific, lovely question, Ajay. Superb. It makes a lot of sense. It depends on where you want to use it. When you say engineering company, I'm assuming maybe it's services or you're producing equipment. I'm not sure. But we know that if you're looking at services and you're doing engineering services for customers, then we don't call it Industry 4.0. There's a terminology called operational technology, which basically addresses similar type of analysis that we are talking about here today, but it looks at the service part. It looks at how well you are managing engineering services. So, but if you're manufacturing machines, let's assume, and you're an OEM who actually supplies machines to customers, then it's IoT technology is fantastic because it makes so much sense then to monitor your machines remotely, understand and do the necessary analysis, back end, understanding whether your machines are doing what you promised they will do because you have an R&D division that needs that data consistently. Also, it gives you a chance to ensure your warranties are well managed. Many times, OEMs who manufacture machines have a big challenge where they give conditions for operating conditions for their machines, but they find that customers don't always adhere to it. So if they don't, then obviously warranties are void. But then you know what? When you need a client, you need a client. So if you go there and he says your machine's failed and you know it is all for the wrong reasons, you'll still replace parts because you have to, and you want to ensure the next business order is coming from the client. But how would I be able to use IoT technology to help me there? If you put an IoT device monitoring your machines, the advantage is straight away you start getting data which is related to the performance of your equipment. Plus, you watch all the parameters that the customer is supposed to maintain so that that machine delivers the output that you promised. And then you expose that data to your client as well so that there is no debate when there are warranty issues. So it's amazing what IoT can do for you in terms of, putting this data in a place where it makes so much sense, where you bring in your machine is remote, it's nowhere in your shop floor, you've supplied it. So great idea to use it there. I think maybe that answers a little bit of what Neha Modi was asking as well. So I think I answered that. Ajay asked me, do we need to have a working system at a supplier's place? Yeah, okay, perfect. So Ajay, exactly. So IoT will help you there because it brings that information to ensuring customers don't have necessarily all the IT infrastructure needed. Just the IoT box will pull data and bring it to you centrally, and then you can work with that information. If you don't have the money as well to invest in infrastructure, then there are cloud solutions. iValue, for example, Devang's company does amazing work in terms of the cloud solutions that they offer. So we push data there and make that data available, with a minimal cost per month, without you investing in large technologies, and do the same type of analysis and bring that data to. So it's a great way to make sure when you're working with small and medium-sized companies, they will obviously not do it. Bundle an IoT cost, very, very minimal cost into your machines that you supply, and still give the benefits in terms of the analysis we're talking about. So great. Okay, good. I'm glad Ajay liked the warranty input. I'll proceed ahead, if you don't mind, and I'll address the next set of questions. Devang, can I proceed ahead after the poll?
yeah, let's do that. The poll is done. You can go ahead with the slide deck, and then we can come back to the questions. Yeah, some very interesting questions coming up. Yeah.
I can see interesting results as well of your poll. So the next question that people ask is that what is big data? What the heck is this big data word? You already heard IoT as one jargon. The next is, what is big data? Now, big data is still, I don't think India, I wouldn't say India, I say companies are mature enough to use big data yet. Big data is about all data in your factory. It could be your business data, your manufacturing data, your sales data, all of them. If they can go to the cloud, because owning this infrastructure is expensive, and you have systems that can compute this data and understand and make kind of profiles around how you are doing things. So if you're doing sales, And they realize, you know what, sales is not justifying production. Now who does this analysis? Very tough. But if there's a third system that can compile all this data that's coming in so many areas and starts giving you insights. Big data is about insights in terms of understanding it at a very larger scale. So large companies, let's assume, who have 10 factories around India, or 20 factories around the globe, they have tons of information coming. When their business owner or their CEO sitting in X country wants to understand, what the heck do I need to do now? And I need to compile all of this data to give me an insight. What can I do to improve? So I can ask a question to big data, and big data needs to tell me, this is the guy that's creating problems. If you optimize, you should have benefits. So big data is an interesting phenomenon. It will become a norm in time. Of course, data security and stuff like that is going to be there. People, GDPR, I don't know if you'll have heard of GDPR. GDPR is what the norms that have been set up by the European countries. Google had challenges, making sure GDPR and their data is not shared and not, is not given to people. So this becomes critical. People don't want this data to be safe. I believe a lot of the large companies like IBM and, we have larger companies who will take, Capgeminis, they will take this data and try to create cloud solutions for big data. So this is something that will come in. I believe we will be able to service this in some time, but it hasn't reached there yet. It's a work in progress. I see it coming in the next 5 or 10 years. Can you imagine India is still at 3.0? So we have to get to 4.0, and then we have enough data which we're already analyzing, and then we need to start understanding how. Many of us don't have ERPs yet. We still have tally systems, which is also an ERP, but are we integrating it? Maybe it's missing being integrated. And those are things that are still work to be done. So for me, Industry 4.0 is not an instant thought. It's about understanding it. And today's session is that: understand and then make a plan on how you want to start implementing it. It's very, very important that you think about it and understand what needs to be done next. If you look at why do all of this, okay, eventually we're all business people and we finally look at numbers. And if you look at it here, I created a slide that will give you a quick idea. What would happen if you start digitizing, okay? And the first rectangle that I marked is cycle time reduction. Okay, the first rectangle, which is 40% reduction. Cycle time is when a raw product or raw set of products are manufactured and you create a final product from start to finish. Can I reduce the time to produce that particular product? If I can, the benefits of digitization get you 40% reduction. What does 40% reduction mean? It means all the bottom parts, and we'll share that in a minute. So cycle time reduction, data entry, 90% data entry reduction straight away, because you have digitized, you've connected everything together. So there's no information that's being retyped. So nobody's typing data anymore. Work in progress, WIP is work in progress reduction. 30% work in progress reduction straight away. That means you get to know where things are and where they're moving, and therefore you know exactly what needs to be done. Paperwork reduction, minus 75%, nothing on the shop floor anymore, everything vanishes. And all of these lead to the bottom square that I'll be sharing here, which is straight away 25% lead time. That means now I know 25% of my time I can be accurate in terms of delivery and what I need to do in terms of even ordering as well as delivering. Non-compliance reductions drop by 28%. The major factor is 30% efficiency improvement can take place. 30%, which is huge. And finally, it impacts the quality, therefore less rejects to market. So what does this mean is basically, if you digitize, all of these benefits straight away come to you. And in terms of ROI, what would that mean? Okay, if you're going to spend money to put up an Industry 4.0 setup, what would it mean? Typically, a manufacturing company can look to 2 to 5% savings year on year with an ROI for between 12 to 18 months. This is if you're ready to spend money. In current scenarios, the way we are running, spending money in CapEx is just out of the question. And therefore, innovative solutions like software as a service are available. For example, we offer services like this where we want to make sure that customers are not stopping thinking ahead or innovating. They want to think new. They want to become better. And they don't want to think, my God, I can't spend 50 lakhs. I can't spend a crore. No way. There's no way I can even spend 25 lakhs today. So when they don't want to spend that type of money, then what is the way out? Then you look at maybe implementing Industry 4.0 as part of a software as a service. That means you're paying a monthly outflow, a per machine calculation, 2,000 rupees per machine, 5,000 rupees per machine. People are like, this makes sense. I can justify it in my OPEX because I don't need to think about large amounts of money going out and planning this. So to get to these lovely figures that you see in the center of the screen, it's simple. you need to make sure that you have the opportunities. I know times like this automatically drive us to become innovative. We have become innovative. We have started offering these services straight away on the OPEX model to make sure clients can easily do this over 3 years, maybe 5 years, depending on what's convenient and their structure, because it's a dream, like I said, and I want the dream to be true. If the dream is true, then I need to make sure clients are joining me with that dream, in that dream. And therefore, it only makes sense to support and make this happen. So these are ways to achieve those benefits and to reach those goals, which, trust me, in terms of money are incredible. So in terms of returns and savings are incredible. Remember, these savings are your hidden costs. They're not seen by anybody. They're just saved by you. That means you have a bottom line that starts increasing, and therefore you have more money in your pocket to really decide how you want to position yourself in the market. So that's the focus of the benefit. So Industry 4.0 straight away points you to these figures if you do the digitization and move forward. So fantastic. The next part comes in. So what is the tool that can really help me to begin? What can start this process for me? I want to connect, I want to monitor, I want to analyze, and I want to do some little bit of prediction. Can I do all of this now? And you can. There is this technology that's already been in place. The Western countries have been using it for the past 25 years. It's called MES. That's the jargon word. It's called Manufacturing Execution System. Basically, it means while you're producing, we want to know and start getting information from there to understand better. This is the segment that it fits in. The level 1 and level 2, these are areas. This is a very typical architecture drawing when we look at a manufacturing organization. Internationally, this segment is properly done. They have a level 1 to level 2. They go into the MES segment, and then they have the ERP on top. The MES segment in India is what we have missing. We have the ERP many places, but we don't have the level 1, level 2. I mean, we have level 1, level 2 as well. We started automation, we put sensors in, but we haven't done 3. And why is 3 important? It's everything about manufacturing. What's happening in my manufacturing? The quality people, absolutely. That's what decides my next sale. Materials, are they moving? Where are they? What's happening to the materials? Is my stock okay? Maintenance, very critical department, something that's ignored. I believe maintenance people are important to any space. So it fits these departments and it brings them into the system, but it brings them in real time. That's the difference. It doesn't bring them, it brings them because it's connected to level 1, level 2, which is where your automation systems are. It brings the data real time to the level 3 systems and only passes relevant data up and down. The connections, if you notice, are bidirectional. That means you can pass data back and forth from the layers that are there. It also is a great cybersecurity layer. It protects information here and converts business layers separately. So business systems don't touch the level 1, level 2, where we are afraid that people can control my process remotely. So it kind of creates a buffer as well. So it's a great cybersecurity layer as well because it buffers real-time data with the systems there. So what exactly is this all about? And I thought I'll go a little bit quickly in detail. If you look at production, in the production systems, you have different things that we do on the shop floor. We need to define our resources, what machines I have, who are the people, what are the type of product I'm making, then I need to know product definitions. I need to know scheduling. I want to supply it to customer so-and-so. So how much do I need to produce? 1,000 units per day, per hour. Then dispatching the product, obviously, on the shop floor, making sure it is going from its planned cycle. Is it going to machine 1, then to machine 2 correctly? Is it being left around somewhere in a store and not being processed? Production schedule, production progress. Once it's in the line, how is it being executed? How much time is it taking there? Tracking it in case problems occur, knowing where it is at what time, who's doing what on it. And finally, the analysis, whether it's done what it was supposed to do, did it come out of the machine in time? Then the quality people, involve them in terms of definition of the test. It could be visual definitions. Obviously, I could look at a product and decide the color is not right, or I could look at a cap and see it's not capped for bottle manufacturing, define those tests, or measurement related data, execute those quality plans, and make sure you do analysis. Why are products being rejected? What is my biggest problem that's rejecting products? So that's the analysis part. Maintenance guys, bring them there, give them plans so that they can execute their plans. It could be time-based. It could be, automatically breakdown-based. They should be able to do it, execute. And finally, the analysis on them as well. How fast are they supposed to do it? Do they have enough stock of materials to repair quickly? Stuff like that. And finally, the materials movement and dispatching of materials on the shop floor. So if you look at it in more detail, you have the production management module. It should be modular so that as a customer, as a person who wants to start using Industry 4.0, these technologies must be modular so that they can be picked and put in only when needed. And then, when I have more money, I plan and add those modules in, because everything is not needed now. You can, though you'd like everything now, it's just not, it defines, costs always will be there. It's a good idea to know how to do that. So if you look at production management, that's a module that should be there. You should have a planning and scheduling one. Preferably, the one we look at doing is dynamic. That means most planning and scheduling are done in Excel sheets, or you have a dedicated, software that does it. ERPs have a planning and scheduling module as well. And normally they're static. They are then released to the shop floor, then the shop floor work. The problem with the shop floor is dynamic. Things are changing. Suddenly they planned the machine to be running 24/7, but it failed. An issue occurred. Now suddenly that machine is not available, and therefore my plan needs to change. Okay, I cannot deliver because that machine is the core machine, and because the core machine is now down, I cannot supply material to my customer. So my planning should change dynamically. I should be able to change it based on what happens on the shop floor. So dynamic planning and scheduling is a nice tool to have on the shop floor. The material management allows me, where warehouse, what material is there, what's the stock inventory, what's the movement of material based on the bill of materials. As consumption takes place dynamically, because you have the production system running, it should tell the material system that, based on the bill of materials, so much material is going to be needed for the next 1,000 pieces. And I don't think it's there in stock. So material management should throw that data straight to you, letting you know that you need to order, else 1,000 units cannot be produced. Bringing quality people in, like I already shared. Many companies like pharmaceutical, automobile companies need tracking and genealogy. Genealogy basically means historic data related to a product that is shipped out. Serial number so-and-so came back, or a batch so-and-so came back, and you want to know why it was rejected. And therefore you trace it back to understand what created that problem on the shop floor. Finally, using tools like SPC. These are manually done in most factories today. Idea is if you're getting real-time data, might as well start plotting these charts real time. We have had experience with ITC cigarettes, for example, where we saw SPC tools were done manually, though they had machines that were throwing this data out. People were taking slips, reading that and typing the data or replotting charts. The moment they did it dynamically with us, they found that suddenly the charts didn't match. The manual chart and the chart we plotted didn't match. So the idea is to make real-time data come directly so that your charts are more authentic. Again, it's not that we blame anybody. It's more about having real-time data and errors, being removed from the data that is re-entered. No typing, no pen and paper. Idea is to make it all automatic. So using SPC tools to help quality, getting the maintenance guys in there to do preventive breakdown maintenance, understand the assets and the performance that they're doing there. And finally, have a device connection system that can integrate your PLCs, your automation systems, electrical systems, all of them, bring it to these systems so that it becomes dynamic. This device connection module should be able to connect to everybody. A maintenance guy might need it. A quality guy might have a machine that does quality testing. The production system obviously needs it. I need the machine and their information there. So device connection is a great way to do it. So these are the departments that should be using it. Not easy to implement all of them at one given time. So it's a great idea to make it modular and decide which one is your prime importance. And as you move and start getting benefits from the systems that I shared above, start bringing more departments in. The more departments come in, the better are your returns in terms of what I was sharing on the savings slide. So the benefit slides become better if you bring everything in, but obviously constraints are there in every organization, and therefore it's a good idea to focus on what you want to do. So just to give you an idea what the different type of data should be available and type of screens you should be looking at. You should have dashboards like this that pop up, which give me data. If I'm looking at the production, I'm looking at machines, then I want to know what's my OE, what's the OE last month, what's the OE this month. I should have this data on my fingertips straight away available to me. The material system, the production system automatically is a system that will manage all the master data. It does the integration with the ERP, PI systems, business intelligence systems that you have, or even simple integration to Excel, okay? Let's not ignore the fact that Excel is used extensively in every company, and we use it because it's a really, really effective tool, and lots of our data sometimes is there. And it's important that we also take in data, and rather than retyping an Excel sheet into a production system, it should just take it from an Excel sheet. So integration is critical even to an Excel sheet. The production system should look at making you paperless. It should do the real-time performance monitoring, the analysis for you, dispatching the production work order that came in, because you've already informed that this particular product is made on machine 1 3, and 5, then automatically when machine 1 finishes a job, machine 3 should see that job available to them. Automatic dispatching of the work order on the shop floor. So this should be the focus of how you should be looking at it. Web plant analysis, make it easy for managers. Like I'm sharing the screen on the left. That screen helps managers to quickly make decisions and act on that information. Web-based, we talked about Industry 4.0 talking about web-based technologies. These are web-based technologies which allow you easy touch-based systems, even if you're using augmented reality, great, lovely big squares to click on and decide what information is there. The systems must talk to you back. That means I should be able to, if I'm starting an activity, click on an activity, I should be able to select an operator. This operator is coming from where? It should be coming from your access system. If you have a swipe card system in your company and people are swiping cards, then we should integrate that system. And their data should be available to me here as well. I can pop up a list of people who are available in your factory, not the people who are supposed to just be there. And therefore, only those people will be exposed here. And I could get additional data because I want to make it paperless. I can add value to this information. If I'm a supervisor on the shop floor and I'm looking at this data and I have to click on an operator and I don't seem to recognize this guy because he joined us last week, I want to know whether he's trained. Safety training is completed. Does he know his electrical training if he needs a little bit of information? So you could click on that and you'll get all that information related to that person as well on the shop floor using simple browser. The job is to have that information at your fingertips so that people see this data and act. The more this information is available, better performance takes place automatically. You have the right man doing the right job because someone saw that information and took that call. Similarly, machines. I could click on a machine, get to know about it. I could have a video running there that could tell me about the machine and its operation so that I could click there before I start my production. A 1 minute video has far more value than losing that 1 minute later or maybe 50 minutes later because the person didn't understand how to do it. So the great idea is to have a 1 minute video of that machine and how it operates, all the drawings related to the machine as well, available when you click on that button. So then you select the machine and based on information that's already available, I should know which order I want to run, which customer's priority, his data should be showing here. I click on it and I should be able to run it. If I want to know more about it, I can get more data. Everything should be popping up using web technology. So it's light, like I said, we have a Windows system, Linux system, any system, a phone, it should bring information to you and allow people to interact, making it touch-based. So I thought this is a good time to get into a case study quickly to share with you. Devang, this might be a good opportunity for you to also look at a poll at this point. Yeah.
Yeah, we have the second poll ready. So let me just launch it for everyone. Okay. So again, some of the things that you've seen today in the presentation, are they relevant and important for your organization? If you would just like to quickly check your poll and respond. Yeah.
Wow.
Okay, so IoT with AI is actually right there on top.
I can see that. Great.
Yeah.
Nice. Terrific.
Yeah, I'm just going to give it another 10 seconds.
Yeah, as the polls coming in, I'll share a little bit on the questions that I haven't yet done and touched on. I have a question from Jignesh Shah. He says, what time, energy, and cost involved for mid-size manufacturing company to go for Industry 4.0? Okay, great. Lovely question and a very tough one to answer as well. This normally involves a little bit of study to understand what you want to do. Like I shared the slides before, there are so many modules to work with, which ones are important. The focus is to pick those ones. Normally, the way we use platforms and the ones I'm showing you right now, they allow us to quickly deliver solutions in 3 months. Okay, so from ensuring that if you have an idea, the delays that could be there are with the automation systems. Are you automated or not? What type of technology can we use on the shop floor that can capture data? And I'm sharing this case study right now. I will, maybe when we go through it, you'll get a better answer. Though it says Bosch here, don't get confused because Bosch, we think they're global and they're big, but the application I'm going to be sharing is very relevant to your question. So I'll come back again to you after we do this case study as well. I have Mr. Panchal saying, how does medium scale engineering company that doesn't manufacture machine but allied products get on using Industry 4.0 in order to monitor production efficiency? Again, if you are doing that type of manufacturing, again, my case study is going to make a lot of sense. Let's go through the case study today, and Panchal sir, I'll be able to help you there a little bit more. Once we go through it, maybe I'll come back. I'm just realizing these are more relevant questions after my case study. And Ajay Vaishnav asked me, can you please add information how work in progress can be reduced? Brilliant. I think that's a wonderful question, and that addresses some of the slides that we already passed. One of the ways, if when you're able to see data real time on the shop floor, and you're able to know, let's say, the materials in terms of where they are and what they're doing, and you have a stock as well as available, it becomes very critical to know what you need to bring to a specific equipment at what time. Therefore, work in progress in terms of what's happening at a specific machine and what needs to be brought in based on its progress. Let's assume you have a machine that's currently producing and it's reached 80% of its cycle time to produce, let's say, 100 components that need to come out. Okay, just for the sake of numbers, 100 units, and then you want to know, he has a specific raw material that needs to be fed into that machine, and you want that to be available. Again, this is going to be addressed right now in the Bosch case study. I'll share that with you as well, because that's the same problem they faced. So let me go through that as well. And are these modules available like this, available in SAP? Excellent question. Many times you feel ERP and the MES space, maybe are overlapping, but that's not exactly true. They actually complement. There are modules there, and if you've already invested, it makes sense to continue using them, just to integrate them in real time with the MES layer, so that the data that's populated to those layers, like production planning, is there in SAP. So you can push data there to the production planning system, or get data from the production planning system, and you want to do those type of integrations as well. So there are some modules, but not all of them. And SAP is not real time, while everything here is real time. So it's populating data to SAP, so that SAP gets accurate data when the business planning takes place, when they do business planning for the year. So great, we have the polls done, and I think I'll proceed to the case study. I can see the questions are incredible, and we're already at 12. So I'm hoping that we can quickly move through the rest of my slides as well.
Yeah, and then we can come back to questions. Yeah.
Yeah, I think we have a Q&A section. I guess the Q&A is happening while we're doing it, so no issues. We'll use the whole time.
Absolutely. Yeah. Great.
So let's move forward. Let me focus on this particular case study with Bosch, where they had a problem in India. They were manufacturing, they were assembling parts. So they had components, and they had to put them together. They had a line of 25 people assembling those parts. So if I was operator one on station one, I was putting in screws. Then I moved the part to somebody else, and then he was putting in another component on it and passing it on. And they had an assembly line which was manual, completely manual. So they did it, but they weren't reaching the numbers they wanted. They had already thought they should make so many units per hour, but they weren't doing it, and they were missing that. And they came to us, and then we talked to them, and we said, the problem. They said, of course we know the problem. The problem is, how do we solve it? We know the problem is human being, and we don't know what to do. We don't have automation here. There's no conveyor belt. There's nothing. So we were like, great. And they said, the problem is this. When an operator works, he has components. He has to put those pieces in. That means he has a box which has components, and he has to put them in. Now that can get over. And when it gets over, he needs to go to the supervisor and ask him to indent this and get it for him, so that he can continue production. Okay. Another problem that he had is his fixtures. His tools didn't always work. They failed. There's an old tool, it failed, and he needed a new tool. He goes back to the supervisor and says, sir, I need it, which is fine. They'd taken into account these particular delays. The problem was, the supervisor is not always sitting on that chair. He's gone out for a cup of tea, and he's not there right now. And therefore, they don't know where he is, and therefore they don't want to bother to go searching for him. And therefore now the plant is going through delays. The assembly process is having a delay, which they didn't expect. And they don't know how to have the supervisor there always. He's going to go for tea. Even if I regulate him as much as I can, someone will pull him up, someone will call him. And when the operator goes back, that person is not there and not able to indent. So we said, great, this is a simple problem. And we realized, let's try to help them with a bit of technology and help them. So manual process, we just put industrial buttons at each operator. And what they did is they could press a button. If they press a button, so that means the operator never got up anymore. A factory shop floor is reasonably large area space, doing a lot of things. So to walk to a supervisor takes a while. Now we put a button there, and we said, if you press button 1, it's color coded, so it's easy for him to know, press green button, and he'll press green. So green means I don't have parts, or my parts are getting over. So he presses beforehand, and now he knows Supervisor will see that and bring me my parts. So great, I don't need to get up and go. If my tool is bad, I have another color button, yellow. I press that and I'm done. And we have a final third one, which is a red button where the supervisor brings his parts and then he presses the red button saying, it's like what the flight attendant does when they have to service you on a flight. You press a button and it pops up and then they see that and then they come service you and press it off again just to know the cycle time on how fast he's able to do this. Okay, easy to start monitoring cycle time suddenly. And now they didn't get up and they were able to do this. The problem was we created an LED screen, not a computer. We just put LED, the railways old LED system there. If you press a button, it showed station 1 had an issue. So he knows what part to bring there. Problem was he still went for tea. And because he went for tea, he wasn't sitting there. So we used the next technology that was available at that time called SMS, which is available as well today. We push SMS to his phone. Now he might respond to it, or you might say, you know what, I'll get there. I'll just have my tea and then get back. And what we did is if he didn't respond in a specific time to that SMS, it escalated to his boss. And when it escalated to his boss, the boss calls him and said, where the heck are you? We're waiting, lines holding. And he ran back and got it done. Within 3 months of this system running, Bosch were able to up production by 7%, which was huge numbers for them. Because now everybody was working tightly with each other. The right people were getting information when they needed it. And straight away, a manual process was running better than it did before. Now, this is why I wanted to address this particular case study because it's beautiful. It really shows us that it doesn't matter which company and what you're doing. Even if you're doing pure manual systems, simple automation like pressing buttons. No technology, okay? We didn't have mobile phones and smartphones. I'm talking this about 13 years back. We did this project with Bosch. I didn't have smartphones on the shop floor, so I could not have web-based technology. I just had 3 industrial switches. That's it. And that did everything. The only additional technology which is unique was SMS. Thank God it still exists. And it's still easy and it's cheap to use. And we used it. So that's why this addresses Mr. Panchal's, and Ajay's and the different questions that were coming up. It helps to start really making it simple and easy to use even if you're manual. And I just shared a few examples, textile industries, agarbatti industries. These are all human centric systems. There's no real automation. In textiles, we have a huge textile setup, and each one doing a certain function. How the heck do I capture this data? So the idea is to create simple technology that they can press and do what is needed and ensure that you are able to capture and understand. In fact, recently we've been working with a few textile companies. We're seeing a lot of inquiries come in, and they're looking at how to really make it cheap, not very expensive, and still apply Industry 4.0 and bring them those metrics. They really want to know which guy is delaying my shirt stitching. Is the button problem? Is the button available? Not there? Is thread not there? They want to know that. Okay, which station is doing what, and where are the problems? And they're allowing the operators to, the person to capture that data as well, making it really nice and attractive. So we are seeing that whatever process you're in, Industry 4.0 makes sense. So I thought I'll start straight away with a company that supposedly is supposed to be automated or even began Industry 4.0. But in India, they were doing a manual operation, and therefore it works brilliantly to work with them as well. So I hope a little bit of the queries that we've been sharing address this. There is a question from Pramod quickly saying, is planning and scheduling modeling available for demo? Yes, it is. Not today, of course. You could get in touch with iValue and we can set up a specific time for that demo. I hope your team Devang will be looking at that and capturing that information for independent demos related to product. Yeah.
Absolutely. Yeah. We are doing that. Yeah.
Then another question from Deepak says, how are you integrating utility of manufacturing companies and how it can be integrated? I'm assuming utility means your DG systems, energy, and other steam generation and stuff like that. Excellent concept. And the screen that I'm showing you now gives you a little more insight. This screen is basically populating and showing you what an operator is doing, what he has to do, how many quantity he has to produce. And it also shows me there's a square there in the middle somewhere. If you can see it, it's called energy consumption. It starts talking about additional parameters related to manufacturing, because I want to start addressing costs as well. And utilities are cost to me. I need them. And the problem is I have that and I don't know what to do. But can I relate them to my manufacturing? Yes, you can. It could be energy per activity. I'm doing a specific activity. How long do I take to do it? How much energy is consumed? Of course, I believe energy consumption is an interesting analysis. Many places we can't reduce it. Okay, it is going to be needed for production. But the beauty is, once it's available to me, I start knowing, can I make my system efficient enough to consume less? That's it. So if I consume less, I save money, simple. So the savings and benefit sheets, you can see utility information also is valuable because it can help me per activity, per consumption pattern, and start telling me if I make that guy better trained or machine automated, for sure I'm going to be saving money on utilities, which are a payout, which I need to do anyway. And the idea is to make sure I make sure that payout is now very, very just needed for that specific operation because it's really efficient. So lovely question there, Mr. Varghese, super question, because it's exactly the slide that was popping up. So it related perfectly to what I was sharing. So idea is to have slide, screens like this, again, web-based, but if you notice the buttons and the screens are large. Operators like such screens because they don't like to look at small little detailing that normal software systems have. It's great to have big numbers showing up and they know exactly what is left, how much time is left to get it done, how much quantities that I've already completed. They love it. If they're able to see these numbers, they work better because those numbers are popping up to them. And you can have people invest in screens like this dedicated to machine. They know what's the next activity, what's the next order coming in. Everything is available to them, so they know what they're looking for. If someone dynamically changes this, let's assume priority changes. Salespeople say, you know what, forget order one, please focus on order two because that client is going to pay us and we want to supply it. And if that's the case, automatically on the shop floor, dynamically, what he should see is that order. So he knows that's the next order that's coming to him and he will process it, period. So it becomes that priority. Dynamically, the data should change on the shop floor as well. So that making it easy to produce and focus on that order and nothing else. Now, once you have this data coming in, whose responsibility is it? And how do I get to that benefit slide? Why can I get 2 to 5%, total savings? Why? How do I get there? It's to have this data available to the heads of companies. Okay, remember what we're talking about. Industry 4.0 is top driven. It's not bottom driven up. Okay, you have to be an owner to understand that data matters to you. If you don't know that, Industry 4.0 is the wrong start. You just don't. It's better not to approach it at all. If I'm talking to a production head, it's not necessarily he's the right person I'm talking to for Industry 4.0. It's the owner, because he wants this type of data straight away available, because I'm already collecting it, to be available straight to someone who can take a call, who can decide. For example, I should have my effective, the overall equipment effectiveness. I should have the maintenance guy knowing how effective is that machine. Can we talk to the OEM and change something? I should need to know the quality person checking quality charts straight away. Based on a trend that's moving upward towards the control limit, he should react to that data instantly. He should be the one who can react to this information rather than just having data. Data has no value if you don't respond to it. So the response to this data is critical. So whether it's OE, how is the operator, and is he performing well? If I'm looking at the HR and training cycles, I want HR to be focusing on that, saying, boss, look at the operators I have. They're pathetic. They're not able to do it because training cycles are not regular enough. Can I train them more so they get better in doing their job? Or if I'm looking at machine, is the machine doing what it's supposed to do? It's idle too long. I want to make sure, why is it idle? I need to know what are the reasons that are creating that idle time and why not manufacturing is available. We have had examples with customers. Some customers don't allow us to share data directly with their names. So I'll share a story quickly here where data, when it's available and you're able to connect it to the business system, we had customers realizing they didn't have enough sales to justify 3 shifts to run. So it's very important. The production people are running 3 shifts, but there's not enough business coming in. So when you consolidate data, integrate them, then you should know that it's important that analysis should lead you to that conclusion, and therefore act on it. Run 2 shifts, save energy, save a shift, save costs, everything gets saved for that certain shift. So the idea is this data must always be looked at by managers. Okay, if you have an automation Industry 4.0 system, it must be the manager that's involved. That means it is his response that will define your benefit. If he's not going to look at this, you will not derive any benefit. Zero benefit will happen if the business heads do not act on this data. It's very simple. It's simple math. You and I know it because we run companies as well. And if we are not there on this data and acting on data, it's stupid. You'll have problems in whatever you're doing. So the focus is to have these charts easily available. It should be available, obviously, on your computers. It should be available on mobile phones. So the same database there should be there so that nobody can say, I was not there, sir, so I didn't see the data. No, the data is there. Open your phone, check it up. Using cloud technologies, we can push this data and make sure it's available to him wherever he is, so he can act on it. Acting is nothing but a call. Okay, most people think acting is a big job. It's a phone call. I see data and realize, oops, something's going on. I call someone and say, hey, can you address that? I can see there's an issue happening at that point, and done. Invariably, things get better. So a phone with information is very powerful. So make sure that you can also integrate this data to BI systems you might already have, but having it on a phone is very, very valuable. Then what are the different technologies that should be there on the shop floor, in terms of connectivity? Because when you go to a factory shop floor, if I'm connecting to devices, then what are technologies that should be available and should be available to me to start using Industry 4.0 when I want real-time information? OPC is a technology that's standardized across many factories. So OPC, DA and UA, these are jargon words, but important words. I thought I would share it with you because if you're noting this down, then you know these are things you want to be talking about as well. MT Connect is a very standard communication protocol for CNC machines and a lot of machines that people come in from Japan and other countries. Euromap 63 also is a very common one. It's more European standards. So if you're getting machines from there, you'll find them having these standards. GPIO is a little old. OPC is again to database. SQL is a very standard system between ERPs and other systems which we use to communicate data up and down. Messaging systems, we use TCP type of applications to people send data. You have weighing scales on the shop floor, or you'll have some other testing equipment which will be throwing this data on a TCP port, and we want that data to be captured as well. We can also support technologies like XML and JSON, which are technologies used to push data to cloud. Again, Devang and his team know such technologies because they are always working to integrate systems that can work on these technologies. Of course, native device drivers like Fanuc and Siemens, which are very common automation systems which are there on machines. If you have them, makes a lot of sense. So this is just to give you a small brief on type of devices and type of technologies that are there. If they're available, it's great because integration becomes really, really simple. In that regard, then I move on to my next question, my next case study. Devang, I have a pause time here. If you want to run a poll, great idea.
There is no poll, so we'll just run the last one at the end of the sessions. But you may want to just take a look at the question from Mr. Pramod Kasrekar.
Yes. I didn't answer that last question from Pramod. The reason is because we have slides that address it. So the moment I get there, I'll get there.
Yeah. Sure.
This is Tata Cummins. Now Cummins. Tata left the group, left the joint venture. They have a completely automated line. This is a line which manufactures engines. They need to produce engines every 5 minutes. Engine every 5 minutes. I repeat. If you think about it, you realize you're driving a car, you realize the engine needs to come out every 5 minutes. That's a fantastic frequency for production. They have 60 assembly stations. So you have 5 minutes, but it has to go through 60 stations. So you have 45 seconds or less per station. They're doing jobs. This is the exact contrast of Bosch. That was completely manual. This is completely automated. You have people at each station and they're quickly putting parts and assembling it. They wanted bidirectional with their ERP. They had an Oracle manufacturing system, and they wanted to make sure that the work order comes from there and then push data back when the manufacturing cycle is complete, which engine is produced, serial number of the engine, everything has to go back to Oracle manufacturing. So the business system knows exactly what's happening on the shop floor. They had a huge and-on display, and and-on display is a huge LED system that shows all the statistics and how they're performing, how many parts are being produced. They had RFID tracking, so they were a little advanced. They wanted to make sure if the line stopped, then can we continue from there? And the RFID tag would tell us, where it last stopped and things like that. They also had barcode printing. So this was a completely automated line, a very, very challenging project, a very lovely project because they are still our customers. In fact, they like the system that they have now 2 lines that are using our system there. Very, very powerful. So it's a completely automated line, which can also use MES applications. We have all of the Industry 4.0 part, integration to Oracle, integration to test equipments that were there. They had testing equipments with a third party, which we had to integrate and bring information after the testing and the quality system. So they had quality, they had ERP, which are the business systems. They had a real-time, completely automated line. So lots of Siemens PLC was being used there, where we were picking data from Siemens PLC. RFID was another company. We were integrating that data as well. So it's incredible, the amount of integration that we were doing here. And we were pushing data as well to the and-on display that had to show the statistics related to what they were doing in the shop floor. The way the managers worked, and this is what I want to share, why they see benefits, why they start to go to line 2, and why they just stick, why did they even bother to do it? Because Cummins is a company that understands IT well. and they understand if data is available to their managers, they can really keep the line and commit to clients what they want to deliver. And you won't believe, 5 minutes, that 5 minute window is a screen which their managers are monitoring consistently. The moment even one station does not perform as per the number of seconds allocated to it, the manager is on the shop floor straight away. He has a window that divides it between shop floor and here. The moment he crosses that, can you imagine how engaged he is? We're not talking about mobile phones and him analyzing a chart later. He's seeing it in real time. And the moment he sees time crossing the set parameter that they gave to that operator, he goes there and said, what's your problem? What happened? Why you delayed? And they rectify the problem for them immediately on the shop floor. So they are bringing delays down in real time, which is amazing. It's a great company to work with. It was wonderful to do this project as well. And they endorse us. They endorse us as well on our website, which is very nice because they're really seeing the benefits of actually using it. So it's very nice. Some companies come out and they're one of our well-wishers, and it's very nice to see them use it year on year and year, and use the concept of Industry 4.0. These are companies who understand Industry 4.0 and using it very, very effectively. And we're happy to be part of that, that story with them as well. So this was just to give you an example of a real-time system that is running completely automated, completely in contrast to a manual system which we shared earlier with Bosch. What other technologies that we can start looking at? Okay, the moment you bring information and you automate it, we have technologies like WhatsApp, Telegram, and we have something called as a bot, which we IT guys like to use. Basically, these are technologies that that seem Greek to many people who are using it, but it simply means that I can use technologies on phones to integrate same logic. I can talk to systems across and bring information from point A to point B, and then you can take that data and push it back to point A. And bots help us to start using technologies like Telegram and WhatsApp, where you can start saying, you know what, I want to know my machine data now. Can I just get data from machine 5? And that machine 5 should answer you with the related data that you're looking for in a message. I don't want to open up a chart. I just want to know quickly what's happening. I can do that. For example, I'm traveling to another country. Having WhatsApp is easy compared to having, a huge chart pop up, open my laptop, look at a screen, and then hopefully internet's working there and the charts populate in time. Instead, I can just send a command and I can talk to my plant, basically. I can talk back and forth. I can send me data related to images, related to what you're looking at. If you have integrated an online video camera system and it's monitoring your shop floor, you can actually click an image and send that back on a chat. You know that we do it regularly. We are all sharing images back and forth. Using a bot, we can actually do that as well. So our technology now supports that, and that is incredible. I don't see it happening immediately, but I see it happening a year or two in time. We are ready, of course. As technologists, our job is to make sure that it's available and customers who really want to start using it. It also allows us to bring in third-party people to work with our systems. They can query information, and I can send them data that is needed. If you have an energy consultant working with you, I can send him energy data related to my production line, and then he can analyze and call you back and say, I think I know where the issue is. Let's focus on X machine. So you can have third-party consultants working with you using WhatsApp. I don't want them to connect anywhere else. Only the commands that they will send, they will get only related data, and therefore I can share with them, and they can get back to me with that information, making it such a powerful way to get people to start chatting with you. Can you imagine they're chatting with your technology? They're not looking at screens. They're not opening. I don't need username, passwords, blah, 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 all gone. I straight away just send a command that I'm authorized to use because I've added you into my chat group, and that's it. And I get data. It's a very powerful thing. I do see it, and I'm sharing this with you because I know it's worth you understanding that these technologies exist and are already available, but it depends on when you want to use it. The next slide talks about advanced planning, and that was something that was asked, can we do a demo? So this is a little bit about it. The advanced planning is, you can do automatic scheduling of production orders. You can set up finite and infinite capacity scheduling, just like a normal scheduling. You can add constraints to primary and secondary resources. The advantage of the constraints are that it's dynamic. That means if the constraint suddenly does not become available, the plan changes. And then you can allow the system to recheck the plan and change the dates for delivery based on that. You can do, setup times. You can realize setup times are taking more time. You can shrink it here. It will automatically update the production system so that the setup times can be concise and ensure that delivery can take place as you commit. Salespeople can make sure that they do that delivery as per their. So the planning and scheduling allows you Gantt charts to move around, to reposition data, to think of another plan, change the date, and play around so that dynamic plans. Once this plan changes, the beauty is the plan is directly available to the production system. So there's nothing to be done. All the availability calculations automatically go down, and my OE calculations will change dynamically as well, because now I know availability has changed, and therefore the demand is more, and everything can shift because they can handshake with each other. So it's very powerful. It's real time, and it's really, really nice to use an advanced planning system that's dynamically linked to my production shop floor. Material management, goods, where they are they coming to a machine, when did they come, what's the quantity. A lot of integration we do here with the weighing systems, which tell me exactly how much is going where. One of my examples I like to share quickly is a cement plant. Again, I'm not using names because I have certain constraints, but a cement plant that was looking at packaging their cement in 50 kg bags. The moment we gave them a system for this, they were able to understand variance in the amount of cement. They're not supposed to give less, of course, they're supposed to give 50 kgs plus. If they give minus, then they have challenges. So they're supposed to give plus. So they have set up their system to make sure it gives plus. But how much plus? They had a number, and the systems were giving more sometimes. And they were losing tons of cement. A 50 kg bag, but I have maybe 2,000 bags every day. And in a period of 1 year, I'm actually given a lot of free cement to my customers because they were not able to monitor that plus. So the idea is to know that plus and understand that how to make the automation system refined enough to make sure only 50 kg bags plus the tolerance I want is managed. So having material systems are very, very important. They really, really help you save. See, this is not a direct saving in efficiency, but it's saving in terms of what you're delivering. So it matters in terms of the quantities that you want to be using. Quality systems, you have a quality system that should have screens like this, which allow you to chart dynamically, pop up those charts, and then based on certain patterns, maybe alert you as well. Product tracking and genealogy, understanding the lots, the management and backward traceability. And finally, like we were sharing a little bit about the SPC and plotting that we're looking at, all of this data available simply on web-based systems. Maintenance people also having all their data available for specific machines, having their materials and spare parts tracked and traced so that they have it ready so they can address problems in the shop floor. So making them part of the material space as well. So if you have a material space for maintenance, great. They can actually record their movement and their consumption of material as well. Like I said, maintenance for me is one of a very important department. If they're doing their job well, you will find that the mean time before repair is excellent, before failures reduce because spares are available. So they make sure that things are already there. And I'll be sharing something on the prediction part a little later that will give you a little insight that it adds so much more value for the maintenance people in terms of their performance. Great, I've reached that slide. It's the 5.0, getting the AI and the machine learning space into my industry 4.0. Can 4.0 get to 5.0 now? Can I start using it? And yes, our tools provide it. The job is to look at, when you're taking big data and everybody's thinking, my God, I don't know when I'll ever reach big data and when can I do deep learning and, neural networks and all of these jargons are there in the market. People get scared and people are like, God knows when we'll ever reach there. I don't even think I can afford such systems to really put it in place. So we're here to share with you that it's easy to do it now. There's no need to get and worry about those jargons. Straight away, if you're looking at the maintenance, which I was sharing, predictive maintenance. That means we want to monitor parameters of an equipment that are able to tell me patterns. So if I have a pattern, let's say temperature of an equipment normally, is between a certain range. And if it's within the range, I'm quite happy. But what happens if you use historical data? So anything related to AI is about history. It's about data that's happened. And then based on that, I'm giving a thought. Okay. And if I can create a pattern out of the thought, then I can tell someone, I think you are going to cross a limit that will give you an alarm or a damage condition. And a maintenance person, you take real-time data, compile it, you weight by doing, you add its weightage by making sure it's averaged over an hour. It's not real-time single values, but it's weighted data, and you plot that. And when you plot it and you create a pattern and say, if temperature is in 4 hours starts going upward, it means something is wrong, because it should not. It should normally in 4 hours be moving between the mean that it's set at. And that can start alerting maintenance people. You can raise a ticket automatically to maintenance saying, this machine temperature is moving upward and past 4 hours. So before it starts crossing a limit or creates a damage condition or failure, they address it. That's the predictive nature of what we can do using simple statistic calculations like X bar charts. But only difference is using them in real time and then creating patterns. The patterns can be customized between customers because each one want a reaction time differently. There are fast equipment, then you want the reaction time to be much faster. You want maintenance people to come in faster. So you can design that where there's vibration, temperature, pressures, different parameters that are there on the shop floor. They all can be monitored and patterned based on your plant and your factory. And then the maintenance people can be alerted so that they can address the problem well before it actually crosses an alarm limit or crosses a damage condition where replacing a material, an equipment becomes far more challenging than a simple repair. So servicing as against, replacing. So it makes sense. So use analytics to do that. And that's what we can do for maintenance. Similarly, in terms of quality of the product that you're producing, I would love to know beforehand. Why would I wait till quality deviates? I would like to know in real time. Those patterns can also be brought to quality people and they can know beforehand and ensure that quality or the machine. This is basically what we talk about, machine capability. If I have a machine, it's supposed to produce a part with X diameter, with this measurement. Is it doing it? Because I'm constantly measuring. If that data in real time is available and a pattern starts happening maybe towards a higher limit or a lower limit, I start telling the quality people, please check. This machine needs to be stopped. Setup needs to be changed and then start production. The 5-minute stop will be far more valuable than a whole batch that is coming out that is not conforming to quality. It means it's rejected, period. So rather than getting to a reject state, you ensure you're within your control limits and you're ensuring that your quality is maintained, and it always gives you higher good quality products rather than rejects. So this is the analysis that we look at in terms of doing for quality as well. Before I go ahead, I guess I'll address a few questions here right now before I go to my final last case study. We anyway have only 2 minutes left, so I'll quickly address questions as well. What changes required let me see. Okay, what changes in the current IT software? Okay, so Nikhil asked this question. He says, what changes are really required in terms of IT, machinery, software, and stuff like that, if you want to look at it. Of course, Nikhil, this is a point of discussion because CAPEX is like a challenging scenario. Like I said, good ideas to use SaaS models. We are working with IT, like for example, hardware companies. That means people who sell computers. We are working with them and asking them, would they be okay to do rental mechanisms for customers? That means I don't need to buy a server that's very expensive. I can have a rental for the server, and therefore it adds to the OPEX rather than the CAPEX. Servers are not cheap. Good servers that need to have data, have redundant hard disks, something like that costs a lot of money. 4 lakhs, 3.5, 4 lakhs. People don't have that type of budgets, and they prefer that also can be distributed. So we are in conversation with a lot of our partners and vendors who we procure these materials to see these same models, because eventually for them it is shipping material and they are recovering money as well. And for them, that's an advantage. In fact, they might recover a better profit margin, but for them, but at the end of a 3-year cycle, but at least they're giving you the benefit to make sure you have benefited as well in terms of recovering money, in terms of your process and using Industry 4.0 and making it effective. So it's a beautiful question that you asked. And I recommend pushing vendors to start looking at SaaS models, whether you're working with Devang, me, or anybody else. It's a good idea to start thinking service. Can you provide this as a service to me? And pushing that hard on vendors, because that's where we all need to become innovative. Okay, maybe the whole way we approach business will change. Then is it possible for third-party
Ajay?
Yeah, Ajay says it's possible for third-party inspections in performance testing. Of course, absolutely. If you have the quality module, for example, and they have a WhatsApp application, great. We can push the data directly to them on understanding the analysis that you're doing per batch for a specific work order. It could be to customer as well. So they know what work orders are running, and you could then give them that access as well and share with them data. So they believe that it's genuine, it's coming from the machine now. So a great way to allow them. Of course, if you're doing it static and you want to send them the reports, you can send them reports directly as well. We have Kaushik then asking me, what are the key things one should be careful about deploying MES? I think, Kaushik, I covered a lot of them. I would say, I think the key thing really for any of us is thinking. I would put us at the forefront, a thought process before deploying MES, and what are the modules that you really want to pick. Don't pick everything. I don't think everything is needed. Pick what is needed. So really go down and realize, what, we'll focus. Most of our customers do that. If they're very quality conscious, they'll pick production and they'll pick quality. and that's it, the two. Some people have reached quality and they're very happy. They want to then look at maintenance because maintenance guys are giving them trouble. So they focus on maintenance. Or it's progressive. They look at production, then a year later they look at quality, a year later they look at maintenance. So the way to look at it is use time to buffer your experience with MES so that you can get the best benefit. Really, that's the advice I'd say. Key things is thinking. Please think before you make any action plan. Don't implement everything that's there. Um, Case study 3 quickly and questions. If you want, I can only address questions now, Devang, because we're out of time, and maybe I can
We're
leave
almost
case
out
study.
of time. If this is something which we can share as on email, I think that would be great. We can do as a follow-up and send the
Sure.
details to all the participants on email.
The simple touch point here with Cooper Standard is that they got to us because they're the first client who said we want Industry 4.0. So the previous two clients never knew that word existed, but this customer actually came to us saying we want to implement Industry 4.0, and these were the issues they had, and we are addressing them right now. So I thought I'll share it only from that context, nothing more. If there are more queries, it's open. Else you can conclude as well. I hope.
So I think we can open the floor to questions. I would just request all our attendees, guests, if you have any further questions, please feel free to unmute yourself and ask the question directly. And maybe we'll just give it a couple of minutes so that we can address the questions, and then we can just come to the closing part of it. Yeah. So I invite anyone who has a question to just unmute themselves and.
Hello.
Yes.
I'm Pramod Kasrekar from KHS Machinery Private Limited. I'm very happy that there are a lot of things are covered in this presentation. So this is a very highly technical and very compact field. This session, a lot many things are there. We have initiated many activities from this ideas, session, that we are in IoT, started in IoT, predictive maintenance and data analytics, so many things. So I would like to get more and more help or ideas, or maybe hardware or software and devices support from various people like that. But one thing is that we are in machinery manufacturing and we are selling machines to Coca-Cola, Pepsi and beer industry. We are bottling plant manufacturing company. So the first challenge we are seeing is we install sensors and all in our machines and send to customer. But to connect to the customer's machine, first of all, one is whether they will allow us to connect within their system, like Coca-Cola and Pepsi, they are MNCs. Will they allow us to fetch the data from their system? That is a big challenge for us. Connectivity, internet availability, whether they will allow within their network or we have to provide our own network, internet, that is another challenge for us. Data collecting and this predictive maintenance. I will come straight away to the technical point. We are collecting the vibration data because our main focus is majorly on vibration. But this, when we collect the data, but at the end, if we get some insight or this predictive model that this bearing is going to fail or this bearing vibrating more because of particular problem, not let us say loose or foundation or something torque is going high like that. So is this predictive maintenance model available, and can we do this whether it is readily available? So these are the some technical where we are stuck up. We have done one demo, means what can I say, POC with one company, but we failed. So we are further trying to go in depth in this. So I want more information or ideas on this.
Great. I think those are excellent questions, Pramod. Terrific. One of the simple things I'll share with you. GPRS, even if customers are not able to give their network, like you said, MNCs normally have very tight IT cybersecurity rules and permissions and stuff like that. One of the great ways today, especially when Geo came out and started giving data at very cheap rates, and you realize that data actually in India is one of the lowest in the world. We pay the lowest value per month for the data. And I would recommend, since automation data, like the ones you want, for example, vibration data, stuff like that, all of this data is not very big. It's not like we're looking at a movie or we're watching a movie. Our data is very small. very effective. In my experience, we did the whole of West Bengal state using just GPRS, not even 3G and 4G, which had much data, higher data rates. So I would recommend, if you look at IoT solution, then make sure IoT solution embeds a SIM card, finish, period. So you don't need the client to get back to you at all. I can just say this data is coming to me straight away. Except when you're looking at IoT, make sure that it's secure, because so that when it connects to your application in the cloud and you're doing some work, make sure it's secure. But GPRS and base technologies are more than sufficient to transfer this data. Yes, you can do predictive maintenance using this system, where you can use the vibration, and we can connect, for example, temperature in relation to bearing, bearing temperature. So if I'm able to measure bearing temperatures, I'm able to do a little bit of prediction based on the natural paths. Then you can create patterns related to that and start getting alerted, so that you can ensure your equipment is not damaged. You immediately call client and tell customer, sir, right now we believe something is going to go wrong. If you don't mind, here's the data, so that they don't question you. And you say, we have already predicted this might go wrong. We'd like a service point at, immediately if possible. And they would appreciate it, because, then you would actually change the part and ensure continuous running based on the data that you had, not data, not just because you're saying data. So yes, very much, I believe this is an excellent way to use it, and you should use it. Very data packages are very cost effective. So just bundle it in your cost in your agency and offer it to clients. It's worth it. So I hope I gave you a little bit of idea.
But what I have understood, that for the vibration data, when it comes to the raw data, then these other companies who are the service provider like Escape or IFM, and they have their own tool in between. They collect the data, they analyze or process the data, they analyze the data, and then they give predictive feedback that this is going to happen. So raw data as such is not used to the end customer for like us, but we have to insert a tool in between to get the exact prediction.
You're right. One of the reasons that happens is because vibration alone has no value until you have temperature with it. And because I don't measure temperature easily, it's not easy to check temperature every time. That sensor, that data is missing. And what they have done is they have created, based on vibration data, another type of analysis that also give them hints of bearings getting bad or problem areas. So they look at vibration data and able to start understanding when possible situations. You're right. Most vibration sensor companies already have cloud solutions, in fact, ready-made. And that data goes there, it's processed. And then based on the charts that are produced, they look at specific data that give them a clue, because they have been studying it, for a while.
Right.
And they understand that data now is most probably going to create an issue in the future. And they can immediately indicate. So if you are able to measure temperature, then you can do a correlation yourself. Otherwise, it's a great idea. In fact, we also know a few vibration companies where we buy sensors. They have the cloud solution and we integrate with them, because we take the final answer from them, because they do it at a different level. Because my customer, unfortunately, does not have measuring capability, and I don't have a sensor at that point, or they don't want to spend money. Simple cost is, I don't want to spend money. I already bought a vibration sensor. Please go from here. And they want the analysis to be done. So it's a good idea to bring these people. Like I said, technologies are available. Integration is what is important. Nothing else.
Right.
If you can get, so we talk to these companies and we tell them, okay, if you are going to analyze the data for us, we want an integration point. Can you bring the data back to me? So my customer benefits at the end of it. So that's what you need to focus on. That's what you want to ask those companies.
Right. One more last question from me. One last question.
Good afternoon. Here, this is Lal Verghese. We are distributors. We are distributors for Ingersoll Rand air compressors, their power tools, and stuff like that. So, I had asked you the question: how does the Industry 4.0 help integrate the utilities? The compressors and all come under the utility part of it. Say, for example, if you have to kind of, one of the thing which is there, the utility forms the around 50 to 60% of the cost of the manufacturing in certain organizations. So, and again, I have seen, to my analysis, I have seen the companies wasting a lot of money in the utilities, like compressors and all, they are wasting money. So, how come, we can power, I am neighbor to iValue. So, we have our office on the common road. How can we work with iValue and give value to our customer whom we can, where we can understand that, we can provide value to this customer by integrating two set of scenarios. I sell the capital equipment, I value sells the solution for the industry 4.0, the analysis part of it. How can we integrate and work on this front? Because
I
ultimately
think
the energy saved is money saved for the customer. Like,
absolutely perfect. I shared this a little earlier, and your question is right. How do we? That's a good question. One way to do this is to ensure that that benefit sheet that I shared is shared with the business owner, because until someone does not see money, somehow they understand. It's not like nobody understands energy saved is energy, is money saved for me. This is known, right? Any logical person knows this. The problem is I don't have data to justify it. Okay, and a business owner who's the guy actually spending the money. Okay, when I tell him, okay, your turnover is 150 crores, very nice. If you save 2%, what would it mean to you? And then he thinks, what do you mean, 2% of 150 crores for 1 minute? Now he is math. Now he sees a figure. Now he says, okay, how? Then he changes the question to how. And then you say, sir, you have utilities. And then we go on to the solution, because I feel driving point for anybody for savings is money. Okay. All of us are talking today, and why we want to implement Industry 4.0 is money. Can I make money? Can I save money? These are the queries. If my benefit is not clear, none of us want to talk about it. Even if you give me logical reasons, I'm like, yeah, thank you very much. It's very nice to talk to you, and I leave it at that. But if you tell me you are doing 150 crores and shit, 2% means this much money. Oops. He suddenly sees money and he said, oh, this money goes into your pocket. And he's like, I like this idea. Tell me how we can implement it when you can do a POC. He doesn't need to get into nitty-gritties because they don't understand that. But the beauty is you need to drive it always from benefits. So if I don't see benefits, I will not proceed with whatever solution you give me. You can tell me I have the latest solution, latest technology. People really don't care. But if they see benefit and it's connected to rupee, straight away you'll find them saying, okay, come, let's talk, let's go forward. Can you do something? Show me. They will ask you to do all of these. And that's the opportunity that I see for companies like you and me, where the advantage lies. Yeah. So it's important to go through benefit sheets, do the presentation of benefits, because that is a common sense nobody wants to ignore. And nobody wants to ignore that money saving common sense. Okay. So bring it down, show the numbers, and then somehow the math is done. And if they don't see it, and we have done this with smaller companies, I realize we just don't approach them. They're the wrong sales point at this point. We ignore them because they're not ready yet. They don't understand the value of 2 to 5%. Larger companies do. You see the companies I showed you are all companies, at that range or much bigger. And when they did a 1% saving, imagine 7% increase for Bosch. Can you imagine the amount of business they got back, in hand? It's massive. They know the rupee value, and our job is to teach that to client. If you can always position a presentation for that, you will find you'll have very easy pitches, and it's easy to then sell technology to. I hope I helped, Lal. Yeah.
Thank you. It's wonderful.
And we can also connect offline here with Mr. Lal, and then just figure out what needs to be done to take this relationship
Yeah,
forward.
they are my office is at Grand Mall, so
Okay.
I'm just nearby.
Very nearby, absolutely. Yeah. Mr.
And I'm also a
Kastrekar,
BNI member.
Okay.
yeah,
Great.
okay, great. Mr. Kastrekar
me.
also had one more question, and I think we have, go ahead.
Yeah, rightly said by you that there are a couple of things means parallelly going on. Like IoT is a one aspect, but digitalization, digital data collection. There are so many cloud related activities and portal related activities are going on. So I am interested in synchronous data integration part of it. So in the company there is a ERP, there is a HR data, there is a attendance data, or there are some technical data like IoT vibration monitoring, condition monitoring, and some knowledge-based repository we want to create. Training we are giving to the chargeable trainings to the customer. So there are various portals or in segments we are working with the different department and activities. So we are also looking one integrator who can understand a total process, and maybe master data can be connected to everywhere, and some processes are connected, and have a one front page from where we can go wherever we want in the detail. So that kind of services we are looking for. So are you in this business also?
Absolutely. I think that's amazing. That's a need. That's exactly why we have the solution. You might not need the MES solution, but you will maybe need the MIS solution, which basically does, our, we have, in the beginning, I shared some slides about different things we do. One is exactly what you look at. Many of our customers, in fact, do need what you're asking because they have so many systems there and the integration is completely missing and they're unable to compile this data and maybe prepare their own information reports about it. Not necessarily need an MES to do that or an industry 4.0, but they just need the information consolidated, mapped together, single points. Large organizations do this because they have too many complex systems, especially if you have a factory that's running in for 10, 15, 20 years, you'll find you have too many systems, right from manual to automated systems. And compiling and bringing the data and integrating it is one of our core expertise. And it would be great. I would suggest reach out to Devang and make sure that we set up some time to understand again on a separate call. And we can understand, we will send you maybe a data sheet to fill up all your different systems that you want to integrate. And then we'll start maybe working phase-wise to help you to get this done. It's amazing. It's a very, very, very important need. And we can understand how to take that forward without any problem. It's something that we've been doing for many, many years for many of our customers as well. Great. Thank you so much.
Okay. There was a question.
Devang, you're muted.
Hello.
Sorry, there's a question from Mr. Nikhil, so he's just there. Yeah, go ahead.
Hi, Mihir and Devang.
Yeah, hi.
When we're talking about MES, then what type of inputs provided from protocol and from iValue in terms of software integration, in terms of cloud platforming, in terms of IoT devices, in terms of sensor integrity, anything else? What we get from you? And how we connect into our business system, or we supposed to give to a custom place?
Devang, you want to?
No, go ahead, Mihir. I think so basically, Nikhilji, the alliance is basically to deliver a holistic and a complete solution. As you said,
Okay.
Mihir's company has been into the IoT and the industry 4.0 aspect of it. We basically come in with the cloud and the mobility part of it. So we jointly work together, understand what is your requirement, understand what is the landscape, look at where the benefits would come from, the areas which you need to prioritize and start off with. And then once the roadmap is kind of prepared, a roadmap is given to you, shared with you, and then as your priorities would define and as your budget would define, that's how the project would get started or project would get launched. And that's how we typically want to look at it.
To get details, Nikhil, ideas, yes, right from sensor up.
Okay, so IoT device.
Yeah.
Yes.
Sensor up, IoT device design, need for which one, what, all of it we will handle. Right from providing those technologies, designing if required. Like Devang said, we understand what the need is, and then all areas, right from bringing automation, sensors, software, cloud, all of it becomes like a whole offering to you as a client or for your solutions, and therefore makes it very simple because we have all of it. Then it becomes easy because we can address each one. And like I always been sharing throughout today's presentation, throughout a timeline, a plan. When you have a plan, it's beautiful because I'm implementing what I need. Yeah, what I need. Industry 4.0 is surely a time-based plan. It's a 3-year, 4-year, 5-year plan. And you bring in just enough because the plan was made now. You can implement the plan in phases and get the benefits, as they come in. Because cost is the important part, and no one wants to spend money; they want to spend money right, and therefore that plan helps them to correctly position it, and then make it eventually effective in terms of the returns that you want to look at. Yeah.
Okay. Thanks.
Thanks, Nikhil. That's
awesome. Thank you. And I think, Mihir, we have kind of overshot on the time, and I think it's almost nearing to lunch for everyone. So thank you once again, Mihir, for taking us all through this session. It was a wonderful session. We would really look forward to having more interaction with our guests and our participants and share more details with them. Final closing points. One is that I'll just quickly launch the poll while we do the closing as well. And on the chat window, there is a feedback form or a feedback link, and if you would just give about 2 minutes of your time post this session is over, but you would just want to click it now so that it's open in your browser, and just help us with the feedback so that we know what we need to do better, or what we need to bring in terms of the next webinar or the series. So once again, I want to thank all the participants today for taking their time out. We've had a longish session, but I'm sure as the feedback is coming in on private messages also, that it has been immensely interesting, helpful, and sort of a learning for many of us in this session. So once again, thanks a lot, Mihir and Team Protocol, to organize this session with us today, and we hope to do better things as time progresses. So I'm just going to end the poll here, and Mihir, if you want to say a few closing words as well.
No, I'm just very grateful that the opportunity is there. Devang, thank you so much for creating this. Like I said, it's a dream for me. It's wonderful to see people. Based on the questions today, I know that it's touched many people deeply in terms of what they want to do. And I'm hoping that we would be a gateway for them to, actually to reach their dreams as well. So thank you so much for doing this, and looking forward to many more like this where we could help more people out. Thank you very much.
Absolutely. Thanks a lot, Mihir. Thank you. Thank you, everyone. Once again, stay home, stay safe, and we'll see you soon.